on how to select a project or a research topic, and then how to read published research papers. Okay. And we need to do all this for effectively gaining the knowledge, okay, within science or within technology and or within education domain, right. So, let us get started with simple definition of what is research. So, research has been, the word research actually has been defined in multiple ways by multiple people and in different dimensions. So, what is research? It is actually an art of scientific investigation, okay, scientific investigation, and research comes from a French word called researcher. And what does it mean? It means to look for, or sometimes again, you are looking for something again and again, okay, or to investigate or to attempt to find out. This is the meaning of the word, French word researcher, okay, or to do research is to discover something that was previously completely or partially unknown, okay, completely or partially unknown, or it was not understood at all. Okay. So, these are all the different phrases that help us to make out what is a research. So, people say that I am doing some research. So, it may attempt to investigate something or to understand something which is completely not known or partially not known, or it is not understood. Okay. And ultimate goal is to search for some kind of information, some kind of a knowledge from the research. Okay. So, when we do this, we try to find out something using a systematic approach, using a scientific approach, okay. And we try to seek something which are unknown to us, So, we do this in the form of a thesis or a dissertation, etc., and we will talk about this later on. We can also do this in the form of a project, depending upon the kind of degree we are seeking for at a bachelor's level, master's level, or doctoral level. We try to do a thesis or a dissertation or a project, and then ultimate goal is to seek some knowledge out of this which are unknown. Okay. So, what do we do actually with from research? We acquire knowledge. We will go through some steps as to how do we acquire this knowledge, what are the procedures, I mean where do we get new knowledge. Okay. So, we get new knowledge or develop our understanding in several ways. What are the ways? In for example, when we collect data. Okay. So, data in some sense represents facts and figures. So, we try to understand those facts. Okay. We try to analyze the data, we try to interpret them. Okay, and this interpretation gives us another picture of the world in our own way of thinking. Okay. So, that helps us to acquire new knowledge that may be new to us, but it may be old to someone else because they would have already explored. Okay. So, doing research is like a investigation that is intended to uncover interesting or new facts that might come out as a result of the data and facts that we have uncovered from data collection or data analysis. Okay. And research helps us to categorize, describe, explain, evaluate, compare, correlate facts and figures. See the words used here: categorize, describe, explain, evaluate. So, all these words are synonymous, and they to some extent give us a meaning of investigation. We investigate, we try to understand, describe, compare, correlate, and then we express the result in the form of figures, tables, graphs, and so on. Okay. So, we will try to see each one of the words shown here. They also hint us what kind of research we are aiming at, okay, what kind of paper we can write. Okay. So, we will see each of these terms later on, and in what way they align our thoughts for writing a research paper. Even one topic like comparison of methods, comparison of tools, and so on can help us to write a paper. Okay. We will see that later when we discuss about paper writing. Okay. So, the first question is, why do we need research? So, can all of you participate and share your experience, or your opinion, why do we need to do research? There are 5 assets in our group who can help us to get started. To explore new ideas, 1. Anything else? 2? Oh, both are almost similar. Yeah, we got the meaning. So you try to explore some new idea or uncover new things. Yeah. Any other? Point number 2? Yes. Solution to a problem. Exactly. Any other? Any other? 2 points we have got. Yes. Out of curiosity. Point number 3. Very valid point. So some people are very curious. They want to actually know why this is happening, why that's happening, or what is the reason behind this. So we got some very nice 3 points. Any other point? Yeah. So this is certainly an example to do research. So the question is like, why do we even think about doing research? So that is a great application of doing research. But what motivates us to do research? To help the mankind, right? So these 4 points are really very important, and I have summarized them here in 4 figures. Okay, curiosity. See the first one. You would like to think why this is happening. Okay. Second one, problem solving. One of you gave a gave an example that we do research to solve problems, right? So when you solve a problem, okay, you also get an idea about what is not applicable and what is applicable. So in the picture you can see problem 1 is applicable, 2 and 3 have no solutions or wrong solutions. Okay, and that helps us to come up with a plan. So if problem 1 has a solution, we go for plan B or as plan A. So it shows in some sense some alternative scenarios to us, and to reach that scenario we have to solve something, we have to analyze something. Okay, then it helps us to know what I know and what I don't know. So I have 2 columns and I write what I know, what I don't know. To the column where I don't know, I will try to explore something. Okay, or it is also part of assignment. Some people have to do research because it's part of their assignment, part of their job role. Okay, they may be a scholar, they may be a master student, or they may have a R&D role in their office, in their company. So they may have to do research. Okay, some people do it for the sake of satisfaction. They feel good by doing some research. They feel that their purpose in life is now achieved. They have got something. So we have 2 great scientists, both the sides. They might have done by one of these reasons, but ultimately they would have got some satisfaction. They did something great for the space program, and they did something great for the people of India, the citizens of India. So ultimately all these in some way or the other in the back of our mind give us some satisfaction that okay, we have utilized our time properly, we got some new knowledge, we were able to get a degree out of this, we were able to complete some assignment, right. So we see that it has a multi-dimensional perspective. In most cases people do it to earn a degree. You agree or not? So because you have enrolled for a program, bachelor's, master's, you have to get a degree and you have to do research. There is no option. But this is one way to that motivates us to do some research, right. Everyone is waiting for the convocation, the degree in their hand, and for that they have to do anything. So they have to do the research. Okay. People get intellectual joy, and then people do research to face a challenge, to solve a problem, to get respect in the society, and to serve the society by increasing standards of living, by gaining more knowledge. Okay, we talk to people, we get a similar community who also understands research and discuss with them. So in a research institute, this is very much applicable. You get similar minded people who work on different topics. They sit together over coffee and discuss things, not politics, but something which is meaningful, which gives you satisfaction, right. Okay. So I have listed here few reasons that are motivating factors to do research. So we do it for to explore a poorly understood situation or poorly understood phenomena. Okay, let's slowly get into more specific from more generic. So we were more generic in the last slide. Now we are becoming more specific. We are trying to understand a situation or a phenomena Okay. And for this situation or phenomena, there may be some study, or there may not be any previous study. Okay. So we also do research to describe a situation. So first point is we explore a situation which has not been done before, or then we describe a situation. So research will help us to describe something or a phenomena which was not known or partially known. Okay. Then by describing, or after describing, we are able to explain those phenomena, why something is happening, what led to this particular configuration, what led to this experiment, and so on. So this explanation is for the phenomena or situation that we have described earlier. Okay. So explanation helps us to understand different levels of the problem. Okay. And also it leads us to understand the cause of the problem, cause of the phenomena. Finally, using all these exploration, describe, explain, all explanation of the different levels, we are able to use it in some real life situation. For example, predicting the future, or sometimes at unobserved spatial location. So maybe if you have a series of data, maybe collected over a period of time series data, we can think of predicting what can happen next, right. Most of the scientific experiments are also related to prediction. For example, weather prediction, monsoon prediction. Okay. Ultimately, what is that? When you understand something, you would like to predict something. Okay. For example, think about space scientists. So right now they are exploring Mars, but what is the ultimate goal? Ultimate goal is to predict whether humans can survive there, whether humans can it can become habitable for humans. So we are doing some kind of a prediction, right. So by exploring, describing, explaining different phenomena, understanding their cause, that helps us to predict the system for future. Okay. And sometimes at unobserved locations. So we also do prediction to and extrapolate our findings to unobserved locations. For example, we may not be able to reach depth of a ocean, which ranges from 10 to 12 kilometer. In some parts of the earth, in Pacific Ocean, the depth of the earth is as long as 12 kilometers. So we may not be able to reach that point, but with some level of understanding, we can at least predict what might be there at the bottom of the ocean, what can exist, and so on. Okay. So these are unobserved spatial location. We can also now probably we have been able to explore the whole world, because people have developed ways to reach there, but still some locations are not reachable. Or maybe think about extraterrestrial planets where humans have not yet reached. Okay. So we extrapolate our knowledge to these unknown locations or unobserved locations. Generally, these kind of prediction will require us to develop a model, because we cannot spend money, time, and labor to actually do some experiments or actually achieve that in a real time. So what do? We develop a model, and using that model we try to visualize what can happen. So these models they will mimic the real world. We try to mimic the real world. For example, let's say that there is a river, okay, and we need to construct a dam. So as a planner, your role is to assess what can be the likely damage, or what are the villages that might have to be relocated to some other location, because they will get submerged under water. Okay. We cannot do this and then see the impact. We have to estimate the impact before constructing the dam. Okay. How do we do that? We can make a model of a dam, make a model of the river, okay, and then see with this level of water how much area is submerged. So what are the adjoining villages which we should relocate before even constructing the dam, okay, and what are the areas that might be affected because of water? Maybe we will lose crops, yield of crops, and so on. So we can assess the damage and then see, do some kind of a comparison, how much benefits we have by constructing a dam, what are the losses we have by constructing the dam. So if the losses are lesser and gain is more, then the idea is, okay, let's go ahead. But all this decision has to be taken before, and we cannot spend crores of rupees just to do experiment. So we do it with the help of a model. We believe that this model is mimicking the real world, okay, and simulate the model, okay, simulate the model to generate some scenarios. So, if the water level is 30 meter, what is the impact on the surrounding? If the water level is 50 meter, what is the impact on the surrounding? If the water level is 100 meter from the ground, how much area will be submerged? I will keep changing the water level, see the impact on the surrounding. But changing this water level physically is not possible. So, models will help us. Okay. So, we start with exploration of a problem, description of a problem, explanation of a problem. Using that we develop a model, and using the model we predict something. Okay. So, now we are becoming more specific to scientific experiments. So, from till the last slide we were talking in general terms. Now, we are trying to see in science and technology what all we do to solve a problem, right away from exploration to prediction. And ultimately, what is the end goal? End goal is that your model, your whole set of steps here, they help us to get some or to come up to some nice decision, which is relevant for the people, relevant for the society. Okay. What do we try to do? What do we try to answer when we do research? Okay, there are some basic questions, okay, that anyone would like to address while doing a research, and they all start with W. So, think of them as 5 W's. Okay, what are the 5 W's? What is the research? So, I may work on some machine learning, computer vision, you may work on some database, Srinivas might work on GIS. So, what is your research about? Okay. So, let us now try to talk about every domain. Okay. Why is the reason, why do you want to do research on that topic, database or GIS or any other relevant subject, and the reason for why or the motivation for why will come from its purpose or significance. What will happen if I spend 5 years doing a PhD on a topic? How can I contribute, or what problem it will solve? Okay. That solution will be a motivation to carry out my research for 5 years, or else it is easy to get bored and get distracted within 1 year, because it is a 5 years time investment. We have to be actually connected to the subject consistently, or else we might lose interest. So, the significance and purpose will help us to define. At any point of time when we get lost in research, we look at what is the purpose of my research, where I am heading to, what is the significance, and that keeps us back on the track of how I should continue my research and why I should do my research. Okay. Then yes, of course, with this how is also a very important aspect, but how will be a bit vague at this point of time. We may not know how to do this. Okay. Then who will be the stakeholders? So, if I provide some solution, who can use it? If it remains in the library rack, your thesis or dissertation, then it may not be of much use. It will be academic thesis. But if you want that it should directly impact the lives of people, the lives of citizens, etc., we have to see who are the stakeholders. Okay. So, stakeholders can be government agencies, can be citizens of the country, can be patients, can be automobile company, can be software company, and so on. Where are you going to do research? So, you generally we have a study area to conduct the research, or a lab where we conduct research, or we have some location where we might want to focus on, okay, such as a group of people, a set of people, and so on. And when are you going to do research? So, when does not mean when are you starting, when means what is the duration of your research. Of course, it will not happen that we keep doing research for 15 years. So, we must have a timeline, right. We are going to start in 2022 and finish it in 2025, whatever may be the result, that we do not know, but we must have a timeline. Okay. Accordingly, we schedule all our sub-tasks, okay, from December 2022 to March 2023, I will do this, then following from April 2023, I will do the second point, and then so on, make a schedule. So, timeline is something very important, because timeline decides your funding. Your funding might be for a certain period of year, 3 years, 4 years, 5 years. Beyond that, funding might stop, and then the whole project might get stopped. Also there are deadlines, we must respect them, deadlines. So deadlines might be from the organization, from the company, from the university as a UGC rule, or any other organization who might be funding our project. Okay. So timeline is something that we must keep in our mind while doing the research. Okay. Now let's get into discussion about types of research. I hope this till this point things are clear. So as I said, so treat it like a movie. There is nothing to remember and by heart, but just to get some feeling of what we can do. Yes, later on we will get more in depth as to what are the steps we should follow, but for the time being you can just sit and listen and relax. Okay. Okay. Now let's talk about different types of research. Why this is important, why we should know about this, because each of us sitting here in the auditorium come from different colleges, different universities, different subjects, different domains. So all of our thoughts may not be similarly aligned. For example, if I just talk about algorithms, 99% people might feel irritated because that's not your area, right? So therefore the entire domain of doing research has been divided into different schemes or ways, okay, which we will try to see in the following slides. So what is the purpose of research? See that irrespective of the domain, irrespective of the subject, we want to discover answers to questions through the application of scientific procedures. Okay, scientific procedures, not something which is not known to scientific community, not using some kind of a, what is the right word to say, I mean malpractice, or not that way, but using some procedure that is acceptable by scientific community. So we are looking into the science part of it, not the other way which are not used by, I mean, researchers, by genuine researchers. Okay. So let's now get into broadly what are the types of research based on different domains. Okay, irrespective of domains, we will look at what are the types of research we can categorize into. Okay, so we will see that the basic research starts with two terms, in two different ways. One is a quantitative research, other is a qualitative research. Quantitative means quantity means numbers. Okay, qualitative means some kind of a categorical approach, words. Okay, so let's first talk about quantitative research. So most people here who have come to understand statistical techniques may already be comfortable with quantitative research, collecting data, analyzing data, and so on. Okay, so quantitative research deals with numbers and statistics, and most people sitting here, including me, we are actually planning to listen to all the lectures to serve this purpose, how to use statistics in our data analysis. Okay. Qualitative research is more to do with words and meanings. So I cannot say that qualitative research by itself is sufficient. Even as a social scientist, people who are doing social related work, okay, they also do lot of quantitative research. They collect data through questionnaire and surveys, and then they analyze the data. Okay, so quantitative research is driven by numbers, data collection. Okay, and people use graphs, and they formulate hypotheses, they test the hypothesis to confirm any theory or any assumption. Okay. In quantitative data analysis, people collect numbers, these numbers are your data, okay, and use this data to express certain things in the form of graphs, charts, tables, and so on, and in the process to validate something they will form a hypothesis. You will learn what is hypothesis in day after tomorrow. So hypotheses are some kind of a statements that we intend to prove or disprove. Okay, and through these numbers we will try to prove or disprove the hypothesis that will in fact confirm some theory or some assumption. Some theory. So, what can be a theory? Sun rises in the east, right? This can be a theory. Somebody would have definitely hypothesized this statement, sun, and then they have been proved, they have been able to prove it again and again. Finally, we all believe sun rises in the east, but somebody might have definitely assumed this, right? Then only they were able to prove it time and again, and from our last several generations, people have been telling us sun rises in the east. So, we believe it, right? It is a simple hypothesis. So, we can have several such hypotheses in from our day-to-day life experience. Okay. And using this kind of quantitative research, we are able to establish generalizable facts. Sun rises in the east. Water flows from higher elevation to lower elevation. Now, yes, it has been proved that if there is a change in elevation, the water from top will fall towards the bottom. But can we prove that? Yes, people would have proved it, right? And then now it has become a generalizable fact. People have generalized it. Any liquid medium will tend to flow from a height to the bottom or towards the bottom. Okay. So, what are some common methods that people will be using in quantitative research? Common methods might be experiment, collect data every day, get up in the morning, look at the direction, see, oh, sun is rising in the east, note it down. So, 1 year of data will show that yes, sun rises in the east. Or conduct several experiments or observations to show that water flows from a height to a lower level. Okay. There is a nice theory behind this. Okay. I am not going to explain that in detail, but all of us know that every place on the earth, okay, every place on the earth has a height. Okay. And we may have seen this in some location like railway station, right? Station name Bangalore City Junction, below that it will be written 545 meters above mean sea level, AMSL, 500 AMSL. Okay. So, this 500 is a number in meters or units from some reference. Where is that reference? Can anyone tell me? 500 is a reference number, height in meters above mean sea level. Where is this 0? Do not say that all the sea beaches are 0. That is not true. So, if you go to beach in Mumbai and beach in Chennai and beach in let us say Kochi, are all of them at 0 mean sea level? So, where is this 0? From where do we start? Second question, if you say something let us say Bangalore city is 540 meters above mean sea level. Okay. New York is 900 meters above mean sea level. So, do these heights they are consistent? Do they originate from one location on the earth, or each country has their own benchmark 0? Have we ever any time thought about this, like where is the 0, from where do we start? So, each country, just to give you some idea, each country have their own 0 mean sea level. Okay. For us, we have a place called Mumbai High, which is located in Mumbai, that is considered to be 0 for 0 mean sea level for entire country India. Okay. Netherlands and Germany have another another place called 0 mean sea level close to Amsterdam, that is called Amsterdam Gauze. So, Netherlands and Germany have their 0 mean sea level there. Each country developed their own 0 mean sea level. Pakistan has another 0 mean sea level close to somewhere in the Arabian Sea. Okay. So, this has been done. Why? Because before I mean, let us talk about 50 years back. Okay. We did not had this advanced technology to do any global level studies, thinking about all countries, all continents, all globe, entire globe at a time. So, people used to analyze data only for their own country. So they developed a local zero mean sea level called geoid. Now when Google came into picture, Google, the company Google developed several earth related applications, Google Earth, Google Map, Google Earth Engine. Google Map is for the whole world, they never differentiate any country. Okay, so for Google Map and Google Earth, same problem existed, that each country. So okay, before this, you might have seen that Google Maps has an option to overlay terrain, satellite view. There is a bottom option at the bottom left called satellite view, map view. You can always toggle satellite view to map view to satellite view. Okay, when you go for satellite view, you can also make your terrain horizontal. I mean, there is a way to turn it from like this to this, and in fact that will also show you elevation, height of places, like Himalayan mountain will be clearly visible, like some kind of a big structure close to northern part of India if you zoom out. Okay, so Google then landed up solving this problem, trying to come up with a global geoid. Okay, so they wanted to have one concept which is zero mean sea level for the whole world, through which they could assign height to every point in the world. Now it is globally accepted to have zero mean sea level. So we will not go into that, but see that all these were part of experiments, observations. People did experiments in their own countries to find out zero mean sea level. Another related question is, we say that for example, Delhi is 1200 kilometers or Delhi is 2000 kilometers from Bangalore, for example, distance. Can you think of a place which we can say it's 0 kilometer, and from here we measure all the distances relative? Think about a graph paper, there is 0, 0 somewhere. Okay, then with reference to that 0, 0, we measure distance between all points. Same thing happens in data clustering. In for example, in K-means data clustering, we measure distances between two clusters or mean of two clusters within a XY coordinate system. Applying same concept to the earth, where is 0 from where we start measuring the distances? Have you ever like thought about? Right. So I will not get into that area, but all these have been induced or explained through several experiments, through several observations made all over the world, and finally they have been able to answer some of the closed-ended questions. Open-ended questions are very difficult to answer. Every solution may be an alternate solution, but with closed-ended questions you can come to some conclusion. Okay. The other second type of research is qualitative research. Quality. What is a common? Give me an example of a qualitative term. Grade me. For example, I will give you a questionnaire and then give you an option. How was the instructor today? Neutral, good, very good, bad, very bad. So you have to rate me from 1 to 5. 5 is extremely good and 0 means extremely bad. So what is this? Qualitative. You are categorizing my performance from 1 to 5. You are giving me a rating. Now ratings are there in all apps, whether you use Ola or for example any other home delivery, Zomato, Swiggy, you give a rating. What is that rating? That is some kind of a qualitative, you can say, value assigning to the task or the performance of the person who has done the task, right. So qualitative research are expressed in words: good, extremely good, bad, very bad, neutral, okay, used to understand concepts, thoughts and experiences. So I will summarize my delivery system by, let's say, Zomato, by just giving a number. 5 out of 5 means he was extremely good, delivered the item on time, and then the right item was delivered, everything is good, extremely good, right. So we express these terms in words which are used to understand concepts, thoughts and experiences. These types of research, they help us to gather in-depth insights depending upon to what level of in-depth you want to go. If you want to give just a rating 4.9 out of 5, okay, then it's a first level. But qualitative research help us to get into more depth, category wise. For example, did the Zomato person reach your home on time, before time? Did he deliver the right product that you ordered? Sometimes they bring some wrong products also. Okay, how was his way of communication? Was he polite, impolite? Right. So I can think about each of his behavioral terms and categorize them into several ratings. Go in depth. Okay, and then they help us to understand every aspect of his performance in several levels. Okay. So what can be some common ways to do qualitative research? So we can prepare a something like interview questionnaire that is open ended, because we do not know what are the right metrics to evaluate the person. So by some means I will say, if he reaches on time, if he gives me the right item which I have ordered, and if he talks politely, he is good. But for you, these may not be the right criteria. You are looking for something different, some other aspect. Okay. So these are open ended questions. I can develop 20 pages questionnaire and take your feedback. But again, this is open ended. So 20 pages may be sufficient, may not be sufficient. You can still add one more point to that, right? So these are observations described in words. Okay, and they help us to explore concepts and theories. So coming back from Zomato or Swiggy to scientific experiments, they help us to explore concepts and theories. Okay, want a break? Small break, or is going fine? Okay. At any time, please feel free to take a break. Okay. So what have we seen? We have seen two types of broader research, quantitative and qualitative. Fine? Okay. So these apply to all of us in all domain. We all work with numbers, data collection. We all want to categorize things as per our ratings, or not ratings, but some qualitative terms. Okay. So this applies to all of us in all different types of experiments. Okay. Even our grades that we get in universities and colleges, we have like A minus, B plus, B minus. Okay, and before this grade existed, we used to get marks in percentage, 60%, 70%, topper will get 90%. So what are these? We are giving some category to our performance in the exam, right? So see that to everything and in the world, we have assigned some kind of a quantity associated with that, in terms of either quantity or like 60, 70, 80%, or quality, A minus, B plus are the grades of your exams, right? Okay. Then comes some very fundamental research, pure research. Okay. This is not very useful at this point of view to us. Why? Because they only, as of now, they only help us to gain knowledge. Think about reproving Einstein's theory or reproving Newton's law. What do we get? Nothing. I am not criticizing the law itself, but just an example. Okay, we are reproving some fact, that is fine, but is it of immediate benefit to anyone? May not be, because it has been proven so many times by stalwarts that it's already a known fact. Okay, so basic, pure or fundamental research are done merely to enhance our knowledge, okay, and for human, animal and plant welfare, but they do not have a immediate commercial impact. They may not be useful. Okay, you have proved Newton's law, it's fine, very nice, and keep it there itself, right? So these are pure research, and these are some of the very tough research. Getting the Newton's law, discovering Newton's law was, yeah. Sorry, I would like to just state something. So there is nothing to criticize or anything about pure research.
I just want to add.
Yeah.
Without the basic research,
Yes, yes, yes. Yes, yes, yes. I agree. I agree. Yeah, yeah, yeah. I agree. So it's not to criticize, but the point here is that these research are good, but they may not be immediate have an impact on something if you are looking for some application. Okay, they may prove something for, or I wanted, yeah, I was about to say. So basic research are some of the hardest research. Okay, people in doing research in physics, for example, they take 7, 8, 9 years to complete. Not because they don't work, but it's very hard to disprove certain theories. So it's not easy. It's not easy, but we do not get the immediate benefit out of it. Maybe because they may be in the form of some laws, theorems, which might be relevant to some set of academicians who are mathematics, who are people from mathematics or physics background. But yes, I agree. Without basic or fundamental research, we cannot advance our application research. Yes, yeah, yeah, yeah. Yes, 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 yes. Yeah, more output is applied research. Yes. Yeah, yeah, exactly, exactly. Yes, yes. Both are interrelated. Yeah, yeah, yeah. Is fundamental. Yes. If we use it, or yes, yes, you are right. You are right. So in no way I was trying to. Yeah, yeah. Yes, yes, yes. Yeah. Yeah, yeah, yeah. I completely agree with what you are saying. So there is in no way I am trying to say that basic research is not required. Yes, it's required. We have great institutions in India to do basic research. For example, IISc, TIFR Mumbai, NCBS within this campus, they all do basic research. Okay, but we do not see the immediate impact of those research because it may not directly impact every individuals. Okay, but they are definitely important because they, as written here, they are done to enhance our knowledge. Okay, so some theories might have been proved by other people, which we may try to again prove it another, let's say the second time. So we may have done a lot of hard work, but its impact may not be visible in a very small short period of time. But yes, they are very important. We have some great fundamental research institutes in our country. So and they are doing good research. We do not see the impact because they may not be directly related to us. But think of another way, applied research. Yes, we must have basic knowledge from this pure research to be applied in the next level in applied research. Okay. So in the fast moving world, think about Samsung. Okay, Samsung or Apple. Every year they manufacture one new series of mobiles. Okay, we all get impacted. Half of the people sitting here will willing to upgrade our mobile. Okay, so applied research in today's world has shown to be of more impact because it has a commercial value. But yes, all the knowledge that comes for applied research comes from basic research. For example, research on chips, research on microprocessors, research on fabrication, they are fundamental. But now since they have been given a commercial value, they become more popular. Okay. So applied research is designed to solve practical problems. Okay, to solve practical problems of the modern world. Also one point, it's not to favor any particular research. In today's world, in terms of employment, job opportunities, applied research has more opportunity. I mean, because there are more number of jobs to take up. Fundamental research have limited scope because they are mostly taken over in universities, research organizations, where the openings are not that huge. So, so in terms of job or employment opportunity, applied research has more, I mean, takers. You do something which is helpful to the society or to the community, people will grab you like with very good salary payment and so on. Okay. So, applied research is done to solve practical problems of the world. Okay. Practical problems, can we think of some example? Look around our society, look around us. What problems do we face day to day? So, maybe all of you came from different cities, different districts to Bangalore. So, you might have witnessed the traffic problem, great problem actually. So, here in this city it is a great problem. So, for example, I took 2 hours 10 minutes to reach here from my home, and it is not that far, but because of traffic. So, traffic is a real world problem. In what ways we can solve it? People are trying to solve it by making flyovers, ring roads, putting more buses, putting metros, deploying more taxi. In the process of deploying taxi, Ola and Uber are 2 agencies which are getting benefited. They have introduced thousands of taxis on the road, right. So, so to come back to the point, traffic problem is something that is bothering all of us. There are many such problems, water related problems. We do not get clean water to drink. So, all of us have AquaGuard or something at our home. Moreover, the water supply is not continuous, it is erratic, maybe 3 days in a week and then another 1 day gap, then another 2 days in a week, right. So, we do not have proper continuous water supply. So, then people are trying to solve it by doing some kind of filtering, deploying some plants to clean the water, reutilizing the water, right. So, these impact day to day life, therefore, they have gained more importance. Okay. Therefore, they have gained more importance. Then the third one is problem solving research. This is mostly done by companies or organizations depending upon what problem they are solving, and that might be limited to the organization. Okay. For example, let us say for their manufacturing unit, the production is very slow. Okay. They would like to speed up the production. So, how should they technologically interfere that? Should they introduce new machines, robots to increase the production, or they should change the methodology, they should change the material that is used in production. So, these are related to organizations or company that are facing it. Probably it may not be a company, but it can even be us. Okay. So, we also try to solve small problems in our homes. So, that is also a problem solving research. Okay. We try to address the problem in different ways. So, beginning from individuals to companies to organizations, problem solving can be local to them. Okay. Apart from this, there are some other themes of research: descriptive versus analytical, primary versus secondary, conceptual versus empirical. Some at conceptual level, some at empirical level, where you have to do some experiments. Okay. So, is it clear to us? Is it convincing? Anyone has any point to add on to the discussion? Please, you can speak. I also get a bit tired by continuous speaking, and I have the whole day to speak. So, I would be honored if you interrupt in between and share something. Different types of research you are attempting or you are planning to do, anything of that sort. You can categorize them where your research falls, basic research, applied research.
Qualitative research, one of example, and CRISIL care rating are there, A plus, A triple. So, this is the qualitative research.
Yeah, it's a, may not be a research, but it may be a kind of a survey. So, company is trying to take inputs from its customer by asking them to give a rating, and then in this way they will collect all this data and then apply analytics on that data. Okay. So, maybe by the rating they might prove that they are the best service provider in the city. They would have done some analytics and shown that people of this age group, they have from this age group, they have got consistently 4.9 out of 5 rating, so they are among the best. And they can prove certain hypotheses, they are the best, or they may aspire to be best, but for that they need to get some data. So they will collect this data through this questionnaire, ratings, etc. It may not involve research immediately, but it may be some kind of a small survey that might give them some clue. Research would potentially involve more data analytics to answer some question. We will see that later on. Okay. Okay. Now let's get into different types of research, and these are deployed for different domains, irrespective of domain. Okay. Design experiment. So many people in ecology and environment, they need to design experiments in the laboratory or in the field research. Okay. So or let's say in medicine, in pharmacy, people design experiment. For example, development of this COVID-19 vaccine. Okay. So what they do, they will design some experiment to test the medicine, to test the efficiency of the medicine. They will apply or they will deploy this in a controlled, semi-controlled or controlled situation and measure the system response. For example, 10 adults were given this vaccine. What was the impact for the next 10 days? Did they had fever, or did they had any negative impact? How many were? How many of them didn't had any impact? So they will do some research before it is approved for common use. Okay. So there can be many such examples of controlled experiments. Okay, or it can also be semi-controlled when not all the parameters are in our control. Okay. For example, when we administer a medicine, okay, our role ends there. We have, but how the body responds is not in our control. Right. So this can be a design experiment. Then any other example of a design experiment you can think of? Suppose if you claim that water supplied in your area is contaminated with following 1, 2, 3 ABC types of chemicals. So can we think of designing an experiment to prove this? So let's say every day, every morning you collect some water in a beaker and do some scientific experiments, okay, to calculate the quantity and types of contaminants in that. So it will be a controlled experiment. So after a month of observation, we will conclude that the water in my area has these following chemicals which are not good for health. Okay. Similarly, we can maybe do a study for a lake. If a lake is contaminated, we can maybe collect samples every week, every month, do some design experiments and conclude something. Okay. Next one is systematic observation, example survey or community meeting. So here the researcher will make measurements or observations according to a plan, but without complete control of the process. Okay. So see that in the first design experiment, you have some control over the process because you can design it and literally look at the impact. In the second one, you do not have control over the process. Can anybody think of an example to this second option? What could be a potential problem where we can apply systematic observation? Example, resource survey or community meetings. Any example? Sir, any example? The second one? I mean, we can be closer to that, we don't have to be perfect. Any example that we can think of systematic observation? Atomic taste? Atomic test. Okay. Systematic observation. Any other? Yes, that can be an example. Hmm. Yes, dietary survey. So it's more like a resource survey, or we are meeting some community. So think about this plan. Government has a scheme to provide meals to children in the school, and we would like to see how the free meals given to children impact their health. So some schools, we have heard in news that they do not give the right nutritious food to the children, even though they get the money for that. So they may have to serve item A, B, C, but they will do cost cutting and may only serve item A. So then how is this impact? How is this scheme impacting the children's health? We can do a systematic observation, but the results is not in our hand. It's without our control. Right. So we can do a survey, resource survey, and then conclude whether this scheme was successful or not. At what level, at what level this scheme was great, and to what level it was not at all useful. For example, in cities this might work because people are more vigilant. They know about the scheme. In villages it might fail because people may not take the responsibility to supply those items to the children. So we can conclude something where all it got success, where all it got failed, right. Then system design. So system design is more like a, think of designing a system. What kind of system? System, for example, a database system. A database is a collection of data in the form of tables, okay. Or think about modeling a system. Think about modeling some system, okay. So here in system design, we try to prove something. What do we try to prove? We try to prove that this system what we have designed is better than previous systems, okay. So what can be an example? An example could be a model. So there might be already some model existing. We design a new model, okay, and prove that, see, my model is better than the previously designed models with some facts and figures. I can prove that, okay. So this comes under system design. Designing of algorithms, methods in computer science, they all belong to system design, okay. Then comes synthesis. In synthesis, the researcher will impose a new conceptual framework. New conceptual frame. What is the framework? How do you define a framework, or what is the meaning of the word framework? What is a framework? Something like a architecture, outline, something like or outline, right. So the researcher will try to impose a new idea, a new outline, okay, and will try to prove that this new concept is better than the previous one with some evidence, okay, with some explanation. That will be, the evidence will be followed by some explanation, okay. So this is called synthesis research. Then people do modeling. Modeling is a new buzzword. In many theses now you will find word modeling of chemical, algorithm, this, that, okay. So what is modeling? Here the researcher will build a conceptual or computational model. Most people in these days, they try to build computational model. Computation has become so common these days because of availability of good laptop systems, data. People develop computational models, okay, and the model is evaluated by its success in reproducing the behavior of the natural system. So how good is the model that in mimicking the real world? How good is the model in mimicking the real world or the system that we are trying to model? If the model is, for example, let's say we develop a climate model. Can I use the climate model to predict next year rainfall? How good it is in predicting the next year rainfall? Okay. So, that is all comes under the broader aspect of modeling. Then comparative studies. Comparative studies is very easy to do, and it is very useful. Common examples of comparative study are survey papers. So, when we actually start working on a new topic, we begin with survey papers. Survey paper is a compilation of large number of papers in one paper. Okay. And in the survey paper, typically people compare different methods, different techniques. So, we get to know all about the different works in one paper itself. Okay. So, in comparative studies, people compare different technique or set of techniques based on some common criteria, and this common criteria is the basis for comparison. So, we try to see what all parameters have been taken into account in all the models, all the algorithms, all the solutions, and in what way they differ from each other, and in what ways they are similar to each other. So, what will this kind of a comparative study do? In fact, we do this kind of comparison in our day to day life every day, in everything. For example, you want to buy a TV, okay, you pick up Samsung, you pick up Sony, Panasonic, do a comparison. I have some criteria. I want a big TV, I want a 65-inch TV, I want a remote control, I don't want to have a separate dish connection. So, that should have a software that if I connect with internet should get all my channels, and so on. So, I have some criteria, and then based on those criteria I will compare the different brands of the TV, and then get an opinion which TV suits my need. That is a comparative study based on certain criteria. So, we have to list out what are the factors we have taken into account while comparing these objects or systems or models or methods. Last one is data mining. So, don't take data mining as a word only related to computer science. Now, in today's research arena, data mining has become popular in all domains, because every one of us are sitting on data cube, or let us say like for example, think about any domain, market, retail, etc. Everyone has collected gigabytes, terabytes of data. Okay. So, irrespective of the domain, data mining applies to all, and one can easily do a thesis or a dissertation only by using data mining on their own data. So, for what do we use data mining? We use data mining to look for unexpected patterns which we would have not even thought of, or which is not trivial at all. So, we may have seen the data many times, but largely because of its size, we may not have been able to see that pattern, hidden pattern. So, data mining will help us to extract those patterns. Can anyone give an example of what kind of pattern we can mine from data? Rainfall. So, let us say if we have 100 years of rainfall for a city, now you apply some data mining. So, what can we extract? Seasonal distribution, whether the rainfall occurs in the month of July every year, has this been a pattern in the last 100 years? If not, in which year we did not have a rainfall, then it can be a drought. So, if there is a drought, what is the frequency of drought in that place? Does it occur every 25 years, every 30 years, or it occurs once in 100 years? So, we can get lots of information by looking at the time series data, which we may not have expected just by looking at it, but your data mining technique might reveal it. So, see that data mining here was applied to rainfall data, which comes from some instrument from a different domain. I can apply it to marketing data, and I will try to analyze your purchasing behavior. How frequently do you order food from outside using Swiggy and Zomato? Okay. Accordingly, and which are the restaurants that are your favorites? Accordingly, I will customize your offerings. I mean, give a discount to you if you use this particular restaurant for this item. I will customize your requirements and attract you to buy my product. Okay, so I don't have to give a general discount to everyone. Looking at what is your interest, I will only provide discount to your interest. So data mining has now here been applied to a market research. Likewise, it can be applied to any domain. Okay. So this part is done. Types of research we broadly looked into. Okay. And what have we looked into? Design experiments, systematic observations, system design, synthesis, modeling, comparing things, finally data mining. Okay. So from your data, you can make out where you can fit your problem statement. Do you want to compare things? Do you want to design a system? Do you want to do a systematic observation? Do you want to design experiments for your work? Okay. And now we will get into the next topic of how to select a research topic for different levels. Okay, this may be so there is no differentiation here in terms of any degree, but in general we can apply this at any level, be it a bachelor's level, master's level, doctoral level, or even postdoctoral level. Okay. So what makes a difference between these different levels? All of them are doing research projects. So what is the point? What is the point that makes a difference or differentiation between these different levels? Bachelor's, masters, PhDs, postdocs, researchers, all of them are solving problem, doing experiments. So what is that differentiates them? Intensity and duration, scope of the work. Yes, he is exactly right. Scope of the work. So depending on the time allocated to you, your scope of work will change. I'll just take one call. There is a urgent call. Just give me 1 minute. Okay, shall we continue? Okay. So, in this portion of the talk, we will see how to select a topic for your dissertation, thesis or research. Before we start, let us first differentiate between the two words thesis and dissertation and project. Okay, we all get, sometimes we use the word interchangeably without actually knowing the meaning of that, and that is fine, there is no wrong in that, but let us try to see what is the difference between these three, then get into the problem formulation. Okay, what is a thesis? So, a thesis is a statement or theory that is put forward as a premise to be maintained or proved. Maintained or proved. It is a statement or theory that is put forward as a premise to be maintained or proved. Any example of a thesis? One line example. So, what is this? A statement or theory that is put forward to be maintained or proved. Sorry, I didn't hear. Artificial intelligence can solve the traffic problem, but is it already a theory, or is it already a statement that has been proved earlier? Until we have seen or experienced any example, we may not be able to claim that this is a statement. So, this might be your opinion, but is it a statement or is it a, so think about something which is theory.
Impact of mergers and acquisition in banking industry.
Yes. So, impact may be a theory. Assessing the impact of merger and acquisition can be a theory, right. So, we might be able to maintain this or prove this and using some theory, using some data or examples. Any other thoughts? Newton's law, it is a well known fact. So, we may be able to maintain it, or we may be able to prove it with some data and with some experiments. Okay. So, anything that exists in the form of a statement, we may be able to maintain and prove, that is a thesis. So, what it is? It is in fact a dissertation involving personal research. You do your own personal research on established fact, okay, and typically the aim is to get a university degree. So, we take some fact, we try to prove it again, and this is intended for a university degree. Okay. It can also be in depth. It can also be in depth, and it can be generally it is a compilation of different researches. So, you may have read several papers and you compile them, compile the findings of all that. Okay. Compile the findings, and also you critically analyze those findings. Okay. What is the overall goal of a thesis? Why people do thesis? Why does a university ask you to do a thesis? They ask you because they want to ensure that you have the ability to demonstrate expertise and knowledge in your area of study, because you have read several papers, books, and you have been able to prove something which is there. You have got an in-depth knowledge. Okay. So, what will a thesis require? It will require a research on your selected topic, proposed or a possible solution, and you try to prove your hypothesis. How do you prove? Using some theory that you have studied, using some models that you have studied, or using some methods that you have studied. Okay. So, what are the components of a thesis? You analyze the problem or topic, whatever topic you decide, conduct some extensive research, okay, summarize the findings, recommend additional research on that topic, what further can be done, draw some conclusion, and make any recommendation from your side. Okay. Finally, if you have done some experiment, we can also document the results. These are the typical components of a thesis. Now, let us look at what is a dissertation. Okay. What is a dissertation? A dissertation is your opportunity during a program such as your bachelor's, master's or PhD to contribute to new knowledge. New knowledge. See the word here. In the previous case, we were trying to prove a established fact, right? Here you are trying to contribute to new knowledge or new theory or new practices in a field. Okay. So, in some sense you come up with an entirely new concept. You can also develop a concept and you have to defend the worth of that concept. Not only develop but also defend it, that in what way your theory holds. So, you will have to do some data analysis and prove it. Okay. So, in a dissertation you will use others' work by others papers, other researchers' paper only as a guidance. Only as a guidance. You will refer to those papers as a guidance in coming up with your own theory. So, you might read 10-15 papers, but those papers are just to guide you, to help you to come up with your own theory, own hypothesis or any new concept that you want to introduce. Okay. Bulk of the information in your dissertation will be your own, will be attributed to you, because you are proposing a new concept, a new idea, a new model, a new theory. Okay. But in thesis, you usually expand upon a subject that is relevant to your study area. You only expand. So, you take up some established fact, law, a rule, a theorem, and you expand upon that. See the difference, there is a technical difference between the two words. Okay. Let us now see what is a project. So, now we know what is a thesis, what is a dissertation, what is a project. Project is something where you have to utilize all your gained knowledge, in some way use your consolidated knowledge to complete some work. Okay, what is this work? So, it will allow you to integrate all your skills, all your knowledge that you have gained in different subjects, different courses, okay, over a course of a program to accomplish certain task or to complete some work. Okay. So, what is the aim? What is the goal for doing a project? A project is done to test students' understanding and competence. Okay. So, you might have learned different subjects all over your degree program, and by giving you a project, we will expect that you are able to use your competence, your skills to complete that project. Okay. At the same time, you may also be able to expand your knowledge by working on that project. Expand your knowledge by working on the project, but with limited research. So, maybe you may go for 6 months internship. So, you may end up doing some work from the skills that you have acquired earlier, and at the same time you might get an opportunity to do some limited advanced research depending on the time. Okay. So, generally a project, funded project, etc., they focus on solving real world problems, or it can sometimes be a hands-on. It can sometimes be a hands-on project. Okay. Whatever, irrespective of the scope, either you do a thesis or a dissertation or a project, okay, all of them will require hard work, commitment, determination and dedication. Some depending on the scope, some might be 6 months, some might be 1 year, some might be 4 to 5 years. And you have to be self motivated to do all this. I mean, for some programs, yes, because there is a deadline, you might try to complete faster because you are waiting for a degree. But for other long term programs, you might find yourself lost on the way. So, it is very important that you are self motivated for the next task to achieve. Okay. And the supervisor will generally not keep pushing you the supervisor may guide you to overcome some problems, may look at the infrastructure issues, may look at some critical issues, but they may not be a day-to-day motivator. So, one has to be self-motivated if you plan to do a PhD, because of the commitment required, okay, and because of the demand. So, one has to treat this seriously. Okay. Now, let us look at the difference when you talk about MTech thesis, MS thesis, PhD thesis. In what way they differ? The only one way in they differ is the scope of the work, and because of the time duration, the scope of the work changes. Okay. So, master's thesis is generally assumed to have a shorter period, 6 months to 1 year. Okay. So, therefore, the scope of work will be smaller, whereas in PhD program you have a wider scope because you have a longer time duration to complete. In doctoral study also you are expected to come up to contribute to some original research, your own contribution. Okay. Therefore, you may have to go in depth, okay, and add some new information to the field. So, at this point I have one opinion. Okay. So, there is a this is not to criticize or have bias against any system, but what you will also witness slowly, that depending on the reputation of the institute, okay, the work done in one degree might even be comparable to another degree in different institute. For example, if you look at a MIT master's thesis, okay, it might be comparable to a PhD thesis from some Indian university. Because of the rigor they work at MIT or Stanford, the master's thesis work and the kind of publication they will get out of 6 months might even be of same standard or better standard than some PhD degrees from Indian universities. So, I do not know, you may not agree with me, but with my interaction with people, I have seen this, and they might have 3 papers only, but all will be on very highly rated journals. So, it also depends on to what depth you are working. So, even in master's thesis somebody might go to a depth where in some universities they do it in a PhD level. Depends on the area, depends on the interest, depends on motivation, and this is how these big companies, Google and all, they hire these people. They look at the kind of publication. So, try opening the Google employment page sometime, okay, and look at their requirements, job requirements. In one of the requirements, apart from the degree, they also require the candidate to have published high quality conference papers only in ABCD conferences, not in any other conferences. Only those people are eligible to apply, others need not even apply. So, I was talking to somebody and got to know that Google receives almost 60 applications every hour for job, and they have developed the AI based system to reject the application, because they cannot deploy humans to go through each CV and then decide to invite them or not to invite them. So, because the AI driven software looks at the keywords in your CV and then decides whether this candidate should be further invited or should not be invited. So, they have a list of only these conferences you should have paper to apply. Okay. So, you will see that many of such high standard universities, their candidates are able to write papers and get their papers accepted in these high end conferences, because of the quality of work they would have done. Okay. So, this is just a personal observation I have seen. Do not take it seriously. Even at any stage, people can do very good things and publish in high quality journals, but depends on, in some places even at master's level you will be able to see very good thesis that might correlate to some PhD thesis. Okay. So, this is all about difference between the scope of the work and the duration. Now, let us get into another interesting area of selecting a research topic. Okay. Any questions, opinions, feedbacks, your your experiences, what you want to share? So we have 5 faculties here. I mean what I know. So from your experience, anything you have observed in among students?
In biological research, we don't consider rating a conference paper.
Yes, exactly. Yeah.
Usually
Yes, journals. Yeah, journals. Yeah. Yeah. So in basic science, pure science, uh, conferences are not that important. More important is journal publications. Okay. So in computer science, conferences have more weightage, but in pure science, journals have more weightage. So people look at your CV and see how many journal publications you have and what is the kind of impact factor these journals have. Okay, so yes, depending on the domain, it can change. Even in engineering science, some domains have journals are more important. Some domains conferences are more sought after. Yeah, I agree. Hmm? Rating, yes, exactly. Yeah. NAS rate, okay, okay. Yeah, actually in most of the domain, journal publication has higher weightage, always. Only in selected domains you see conferences, because I think one reason for conferences would be that so many papers are getting written every year that journals are not able to peer review them with that pace. So they organize the conference and accept a bulk of them and finish it off. That could be one reason, along with giving the people an opportunity to meet each other and talk and discuss about their research. This could be another opportunity. But yes, most 90% of the domain journal publications are more important. They have higher weightage. Okay. Any other feedback anyone wants to give? Anything not related to anything here, whatever we have discussed. Any of your experience while writing a paper or looking at some different university thesis, what your opinion? Anything is fine, please.
Selecting research topic added to all these criteria,
Yeah.
we need to think of financial
Yes, yes, yes. That is the most important
facility
part
available
actually.
in the research.
That is the most important. Without that, we cannot even proceed. And I will come to this. I will come to that right away from when we discuss about selecting a research topic. So budgeting is very, very important, and facility is also very important. We cannot ignore these two factors at all. Any other thing you would like to share? Slightly louder. No, no, I am not comparing the quality of research in West and East. I was saying that depending on the depth of the research, sometimes we will see that even a master's thesis is as good as a PhD thesis, depending upon what kind of problem they have solved, where they have published. I am not commenting on Western and Eastern research. Yeah, yeah, I agree. I agree. Yes, yes, that is completely true. Depends on the facility and training and environment, research environment. These are all very important factors. We cannot ignore. Yes. Yeah. So in no way I am comparing and commenting anything on the Western and Eastern publication or ranking. Nothing like that. Just saying that you can even find a very good thesis at a master's level. Sometimes as good as a PhD thesis. That was just my. So depends on to what depth people have gone, to what depth they have looked at the subject area. So you may have also heard some people completing PhD in 2.5 years, 3 years with good number of publication. So it is because they have a very focused objective. They know what they have to do. They have the required skills. They have the required facility. They have the right environment. So that is what everyone needs. So why they are able to do so good in that? Because they get all the conducive environments. So therefore they excel. So I am not commenting on any system, but in general you will even see that people do PhD in 3 years, some people do it in 5 years, 6 years, some people number of publications in PhD will be same as somebody in masters. That is also possible. Okay, let's not talk about the comparison. It was just opinion. Okay. So please don't take any such opinion as strict thing. It is just to give some thoughts about what do we see, what kind of patterns we observe. Okay, this is just observation. It may be wrong also. Okay. So now let's get into interesting part, how to select a research topic, and this is very very important because this gives us the direction. Okay, we may have 5 years to get a completed degree, but until we have a nice topic and direction, we are all lost actually, right. So how to search for a topic that will keep us motivated for the next 3 to 5 years for a master's or PhD program. Okay. So first task is to pick up a research project topic, okay, after having seen the background, okay, and we try to categorize the kind of research into 3: application, algorithmic, theoretical thesis. Okay. So application thesis nowadays has become very common. Why? Because they have a short term impact, not short term, but they have an immediate impact on something which might help us to solve a real world problem. Okay. And since it is applied, so you don't worry about too much about developing the method, but rather our focus is on using an existing method to solve a problem. Okay. So this is by far the most common. Pick an application that interests you, okay, and explore how best to apply methods to solve it. Pick a problem and explore in what ways we can solve it. Okay. Second is the algorithmic thesis, nowadays becoming popular. Okay. Pick up a problem or a family of problems and then develop new methods, new algorithms, or a novel method to solve the problem. So you might be able to address one single concrete problem, or you might be able to address family of problems. For example, let's say if I say traffic problem in cities. So traffic problem is one problem in one direction I can try to solve by giving some solutions. Now if I talk about the city and then say that in the city has problem about traffic and cleanliness and then water supply. Okay. So all this is happening because the city has been growing in at a faster rate more than its carrying capacity. Okay. So if I address a few problems in a growing city, I may be able to impact traffic, I may be able to address some traffic problem, some cleanliness problem, and also some water supply problem. So I will be able to tackle family of problems. May not be able to give 100% solution to each one of them, but would be able to address them to some extent. Of course, there is no right solution to the traffic problem even today. Even if we have introduced several modes of transportation, even cycles and two-wheelers, four-wheelers, metro, bus, train, but still that problem exists because they are something like open-ended, because the population keeps migrating and in the search of employment, education and so on, and the resources are constrained. So that problem is never ending. Okay. Then comes theoretical thesis. Okay. This is by far one of the difficult one. Again, this relates to in some sense this relates to pure and basic research, fundamental research. This is one of the toughest. Why? Because you are trying to prove or disprove some non-trivial properties, which is not at all easy to extract or understand and explore very easily. Okay. So think about some laws in physics, some theorems in mathematics. Okay. So here we have to prove some interesting non-trivial properties. Okay. And also people come up with new or existing methods. So all the new discoveries that happens in pure fundamental research, theoretical research. Otherwise, most of them are applied research. People have now started calling applied research as trans-level research. Translational research. So there there the understanding is that um, you translate your idea to solve some real world problem. Don't only keep it as a theory, but move ahead and try to apply it and solve a problem. Okay. So, by far therefore, those are more common, and theoretical theses are lesser common because they are actually difficult, and because they are also purely theoretical, but they are, yes, again very important for all your application and other model developments. Okay. So, last one is that you combine all this application, algorithm, theory, and make another thesis, khichdi kind of thing. Okay. So, one can also make a khichdi as a thesis. Khichdi in the sense, combine all this, develop one method, apply it, solve some problem, submit your thesis. Okay. So, it need not only adhere to the guidelines of what is written here, you can mix and match and write your thesis. How do ideas come to our mind? How do we start thinking about problem? Why these slides are important? So, many of us who are planning to apply for PhD, you will be asked to submit a statement of purpose. Okay. And statement of purpose will define what is that you plan to do. Half of the applications will get rejected because the candidate is not at all clear what they have to do. Not even, they don't even know the domain properly. Just because the current buzzword is data analytics, machine learning. I want to do my PhD in machine learning. But what you want to do? Machine learning is very broad. Data analytics is very broad. So, we must be a bit clear in writing that statement of purpose, and this applies to all foreign universities. Even if you apply there, they will ask you to submit one letter of statement of purpose, and where we have to define not only statement of purpose. There is one more document, statement of purpose, and I think statement of work. One document is why you want to pursue that degree. Other document is why you want to do that degree. Other document is what you want to do in that degree. Sorry? Scope, along with scope, it is called statement of purpose, and one more statement of, sorry? No, not need. Other is in the other document you have to clearly talk about what is that you want to do. Yeah, something like that. So, there is a specific name to that document, and when you apply, they will ask you to upload letter of recommendation here, statement of purpose here, and so on. So, there you need to actually be very clear what is that you want to do. If you say I will do something, then it may not, there is a little chance of getting accepted. So, I want to do something in machine learning. That is a very vague statement. So, until you show more clarity, it does not reflect how much background knowledge you have. Okay. But question is, from where do we get these ideas, whatever we want to do. Okay. So, most fantastic projects, thesis, they come from either the application area or a area in which you are interested in. Because application area, why? Because you always see some problem around you and you want to solve it. Rather than getting into too much in depth, you want to solve that problem. So, it becomes an application. Okay. Or you pick up something, some subtopic in which you have great interest. For example, you always hear about data science, but would now like to apply data science to your domain and actually see in why data science is becoming popular. Okay. And so, pick up some topic that gets you excited and passionate, or else it will be difficult to keep you motivated for a long duration, 3 to 5 years. Okay. So, this is very important, but at the same time I will also state later on that do not pick up a topic that is too much overwhelming. For example, study of rocks and minerals on Mars. So, right now getting data itself will be difficult. So, how do you even wish to complete that project, right? So, pick up a topic that is reasonable That is reasonable in various sense. We will talk about time, knowledge, skills required, professor's guidance. He should be aligned to your area. If he works in some other area, you pick up some other topic, then interaction will become very less. So then his support will be lower, right? So we have to keep in mind all these important factors. Okay, good way to start is you have some topic in your mind related to your area. Then also look at previous batch thesis, and there are many theses now available online in online library, okay, of many university institutes, and they have some really great ideas. So browse the digital libraries of some universities. They have their MS PhD thesis already in the form of PDF. You may download that, look at that what they have done in that work. So there might be some institutes which are really very pioneering in your domain, some departments in some universities which are very good, top rated in the world. So you can look what they do in this area. That might give us some clue what problem we can tackle. Okay. Alternatively, if you are already working on some research or industry sponsored project, so many of us get a chance to work on some sponsored project. Why? Because that sponsored projects gives us our salary or stipend. Okay, so they fund us for 5 years, and our salary or stipend will come from that project. So if that industry has given us a problem to solve, we can think where we can align our knowledge to solve that problem. So if you want to, let's say, apply machine learning, deep learning, or any specialized skill, where do we align in that bigger project? Okay, and again, please do feel free to propose ambitious things that you are excited about, but not overwhelming things. Okay, right. So now sometimes you may be part of a bigger project in your university, which has got a grant from UGC, DST, VGST, and so on. So you will have to align yourself to one of the research problems, challenges in which you can contribute. So for that, you have to discuss with your supervisor or whoever has got the funds, and see in what way you can contribute. Okay. Most of the time these projects will be time bound, 3 years, 5 years, and they will be inclined to solve real world problems. So these are actually a very good opportunity to work, because problem statement is defined. You know what you have to achieve, rather than it's open-ended question. They will give you a specific problem because it was approved by the committee for funding. So you know what has to be done. So be a part of it and get the work done. This is the right way to do things, degrees in lesser time, 3 to 4 years, because objective is clear. You know what you have to achieve, you have to find out the path. Okay. So from where all you can get ideas, look at the MS thesis, PhD thesis of different universities online. Okay. Talk to your supervisor, they may have funded projects with some sponsored projects through which you can be part of that and align yourself to that and finish the things on time. Okay. And also ensure that whatever topic you work on, it has interest to you. Even if it is sponsored project, you must have interest on that, or else it will become like a burden. Instead of completing, we will be striving to survive there. Okay. So this is, now you got some idea about doing research in your domain. Okay. Now next what? I got something to work on, some topic, through some source, project, etc. So we have identified an area of research. Next what? Anyone? I got some idea to work on Mars, but next what? Literature review is still one step ahead. Before that, we have to see something more. Define objectives. Yes, one point. Another point. Point number 1, objective. Point number 2, design of experiment. Point number 3, outline. Challenges. Point number 4, challenges. That is all I have compiled in the slide. Just I am showing you in sequences, and you know the answer. We have to draw a framework, formulate the objective, look at the challenges, data availability. For me, if I plan to work on Mars, I may not have the data. So at that point, leave that project, take up something other, right? So these are the points what you have just stated, which we will now discuss in the next slides.